Hi, um, so now I'm gonna try to solve this problem. I solved the problem maybe like 1 year ago, but now again I wanna try to do without looking into my solution. So the problem is we have a problem name is convert sorted list to binary search tree. And it should be hey balanced binary search tree. So we have already sorted array, and we need to somehow convert it to height balance binary search tree. And let's check what does it mean, height balance. Height balance binary search binary tree is a binary tree in which depth of the two subnodes of every node never differs of two subtrees of every node never differs by more than one. So the first idea I have right now here is to split the sorted list into two, and that's gonna be a binary search tree for the left part and for the right part, and then split it again into two, and then split it again into two. Let's say you have like this tree. Let's close everything here. Let's have this rearrangement. Yeah, so copy, paste. No. Okay, now I will try to do this. So we have 10 minus 3059. Minus 10. Minus 30. 5 and 9. My idea is like split it into two parts. That's gonna be the middle binary tree. And then pass the remainder to the left subtree and pass the right part into the right subtree. And do the same. Split it and go again left and right. So let's assume we're gonna by default. Okay, so if you split it here, there are two nodes. We divide. Let's assume we give a preference to the left side. So we so we find, let's say, we have a length of 2, and then we need to find the middle element. Let's say we do length minus 1 over 2 for the middle index. So here the length is gonna be like 2. That's it. So we have let's say index of 0, 1, 2, 3, 4, and we have left equals, let's say, 0, right equals 4. So we do this left middle equal left plus right minus left over 2. So in this case 0 plus 4 over 2 is equal 2. So we did that, remove that solid. So, and we pass left to the left side, left equals 0, right equals m minus 1 and equal 1. And we do this again, we do left middle equals 0 plus 1 minus 0 over 2 is equal 0. So here we have middle minus 10. Yeah, and on the left side we don't have anything. On the right side we have 3 minus 3. And do the same for the 5 and 9 so far. So for the 5 and 9 we have a left equals 3, right equals 4. And then we do this middle equals 3 plus 4 minus 3 over 2 equals 3. So we have 5 as a middle. Left side is not initialized, right side is gonna be 9. So right side is gonna be right equals left equals 4, right equals 4, and then middle equals, it's just, we can just skip that and exit instantly because left equals right. And there we can skip instantly because like left gonna be greater than right. So exit. Now I wanna, so the question is how we can in a linked list, single linked list, how we can basically do this splits, yeah, how we can instantly access element under index 2, or like how we can do that basically. And one of the idea I have is to save the linked list into array. So the first approach, save into array, and then it's going to be all of n time, and space is going to be also all of n, and then we can pass this array into the function for the creation. Create binary search tree out of array. Second approach is going to be save our space all of 1 and time. So time is going to be much bigger in this case. So every time I want to access the, let's say, nth element of the list, I want to start from the head, and I want to iteratively go up to that point. So we have interim nodes, and then the final one. And the number of, like, let's say, we want to, for the first element, it was a head, it's gonna be n minus 1 links we need to follow, and that's gonna be for every node, because we wanna process in the binary. Wanna recreate binary. You wanna create binary tree from the linked list. You wanna have the same one-to-one matching between nodes in a linked list and a binary tree. So it's gonna be time gonna be order of n, and then in order to access the first, the second, the third element, etc., etc. So it's going to be some kind of this 1 plus, let's say 0 operations, because I had plus 1 operation, plus 2, plus, and then plus n minus 1 operations. Oops. And then if you sum up that, it's going to be n minus 1 divided, multiplied by n minus 1 plus 1 over 2. So it's gonna be O of n squared. So here the complexity is gonna be O of n squared, because for the, like, it's intuitive. So we can either trade off space here, like first, we can trade off space with time. We can either have O of n time or O of n space in the first approach, or we can have constant space but squared time complexity in a second algorithm. Yeah, I'm currently thinking about something kind of mixed approach. If the converting this third approach, if converting this to the double linked list, etc., will it help us? So it will definitely, like, let's say we have this situation with nodes. Let's say we have left and right nodes reference, like head and tail. Head, this is head, this is tail. So in order to find the middle point, we need to do n minus 2 operations, n over 2 operations. So we need to either start from head or go from tail, and then go inside of the linked list to the middle of the linked list, and then have this middle node. And then we can pass their reference to the left subtree, so we can have like m node. So here it was, let's assume, so initially we're gonna pass head, tail, head node, head node and tail node to the root, and then I'm gonna create the root, and then we're gonna pass head, head node, and then middle node, say I don't wanna, like, say the head, like, is previous, and here gonna be mnode dot next, and then tail node. So here, like, in order to find the node, we need to go either from head to tail and go into the middle of the linked list and find the middle nodes, and so n over 2 operations. Here we have to do the same, either from head node or from the head m node previous, and we need to go into the middle of this sub linked list, double linked list, and find the middle element. So it's going to be n over 4 ops, and here also n over 4 ops. So it's going to be on every level, so n over 2, and this is so on and so forth. So how many operations are going to be? N over 2 plus 2 by n over 4, and it's again n over 2 plus we will have 4 by n over 4. So it's going to be again over 8, and then so on and so forth. So I'm going to have n over 2 plus n over 2 plus n over 2 plus n over 2, and the number of this element is going to be the heights of binary tree. So it's like log n, so it's going to be n over 2 log n, something like that. So it's better than n squared. Okay, seems like the third method is a little bit better for the time complexity, but equals like O of n log n. But again, the problem here is that I need to, if I would have a double linked list, it will make my this problem a little bit like better in terms of like space complexity. So the space complexity in this case, I need to create a double linked list from a linked list. It's of n complexity of n and of n time and space. So the total complexity of this algorithm gonna be time. So the time gonna be O of n log n, and the space gonna be O of n. And this approach is it's basically no better than this one. It's even worse. So here was O of n time, O of n space. In here we have this O of n log n time and space of n. So the time is worse, and the space is the same. So there is, if I can just do this array, and it's gonna be the better than the convert method of double linked list. Okay, let's do that. So we have this code. Let's say this one. tree node, we have the node left, right, value, yeah, and I can do this static power class tree node and this one function, and I need this one later. So the first part, I'm gonna go through the, okay, we also need list node here. So my idea is to go through the list nodes and then save that into the array. And we don't know the length of this linked list. So I assume having array list list node and then nodes. But they don't say what's the length of this linked list or the bounds for this linked list. So I would definitely will use a simple plain list array of Java here if I would know the upper bound for the number of elements in the list. But because I don't know that, I'll just use array list here. And then I'm gonna do this for head. Let's say list node current equals head, while head not null. Oh, while current not null. I wanna add nodes, add current, and then current equals current next. This will save this this linked list into array, and then I want to do this private tree node VST. Then I want to have left pointer, I want to have right pointer, I want to have array list, pass to the list node, pass as a parameter, node nodes. And then I want to check if left is more than equal than more than right. I'm gonna return no. If left is equal right, I wanna return new first node, and then I wanna have nodes get, and then IntelliSense is working here. It makes my job much easier, but I don't want to do that, and I don't know how to turn it off. That's interesting. Can I do Leetcode? Java, let's say Java. Coming from Java. Okay, Java. Let's copy this one. Okay. Okay, this, and then this will run. And there's no gap, and then you wanna left, and then well, okay, that's also autocomplete. Interesting. Okay, there's no benefit in using that one. Okay, stick to the Leetcode. Get out, not well. Okay, and then if int middle equals left plus right minus left over 2, and then I wanna do this, and I wanna do the so I wanna create the list node middle equals new 3 node e node e node, and then I wanna nodes get middle, and then value, and then middle left equals bst, left, and then m-1, and then nodes middle right equals bst, m+1, and then right the nodes, and I want to return middle. And here I want to return bst, and then I want to return bst left 0, right gonna be nodes length -1, I guess size -1, and then nodes, something like that. Let me quickly check if it works. So we have this 3, we have linked list 10 minus 10 minus 3 0 5 9. We have, so we will save this array, we will save this list into the array by having cursor going to the next element and like adding that to the nodes, and then we're gonna call this BST that's gonna build our binary search tree by splitting the nodes in like into 2 parts, creating the middle element, and like then calling itself for the left and the right parts of the subtree, and then returning the middle. Yeah. So it's, I can write basically the test for this one BST, but the problem here is that it will be time consuming, and we are currently like on the 29th minute. So I wanna just paste it and see if it works. Okay. Okay, let's submit. Okay. Runtime, not that good. Memory, also not so good. Wonder what's here. What we do here, they do the helper, and so they do find middle. I wonder, like, why Leetcode does this all the time to me. Um, so it's like runtime 1 millisecond here, like runtime is what, 0 milliseconds. And I'm doing this middle element. We are doing a lot of like extra work. Yeah, sure, it's better from a memory perspective. It's like one constant memory, but time-wise, yeah, interesting. And this is head linked list. So this is basically list release. So this is the same as I have. Okay, I will wrap up. So 30 minutes, I spent around 30 minutes on this problem. Yeah, still kind of, it's a borderline, pass or fail. If I will get the second task on the real interview, and the interview gonna be like 40 minutes, it's definitely fail, because like 10 minutes to solve the task, it's the remaining task, it's unrealistic. But if in the other setup, maybe in 1 hour interview, I might pass it. So yeah, I will claim it as a fail, but yeah, as I said,